Hello, everyone, and thank you for taking the time to participate in part two of the schema-based problem-solving training. In today's more advanced session entitled Helping Students Make Sense of Mathematical Word Problems for Identifying Schema Structures and Using Attack Strategies to Solve, we will be applying all that was learned in part one at a much deeper level. Therefore, if you have not yet watched the foundational session, I would encourage you to do so now and then come on back. I had shared in the first session and want to reiterate again just how essential and vital you all as paraeducators are to our instructional teams. And I am hopeful that the strategies that we share today will be valuable and effective practices that you can use to better support your students as problem solvers. Again, my name is Billy Joe Monday, and I am a staff developer at the Lincoln Intermediate Unit, supporting MTSS Math and STEM, as well as inclusive practices. My contact information is here for you. Please feel free to reach out if there's anything that I have shared throughout today's session or from session one that you would like to learn more about, as I am happy to support you any way I can. Throughout our time together, I am hopeful that the information shared will once again remind you of some existing knowledge, give you opportunities to refine those practices, possibly even replace some with more effective ones, and reaffirm the excellent work that you are already doing. In our first session together, you will remember that we explored why mathematical word problems can be challenging for students and how schema-based strategies help our students to make sense of mathematical situations, while they are focusing on those relationships rather than relying solely on keywords. We discussed that schemas help students understand what is happening before deciding how to solve it. We also examined the important role that you all play as paraeducators in supporting student thinking through questioning, modeling, and language supports. Today, we're going to take the next step, a little bit deeper dive. Knowing that schemas exist is important, but students also need support identifying those schema structures, organizing the information, and developing and executing a plan for solving the problem. In this session, we will go into the two major schema families, additive and multiplicative. We'll explore how schema maps and bar models can help students visualize relationships and organize their thinking. We will also be looking at a cognitive attack strategy that will provide students with a consistent process for approaching and solving word problems. As we move through today's session, I encourage you to continue to think about the students you support. Consider where they tend to get stuck and how these strategies might help them to better understand, represent, and solve mathematical word problems. So once again, let's begin with a reflective practice. In session one, we really focused in on why we felt our students were struggling with math word problems. And now I'd like us to change our lens just a bit and really determine where we see the challenges occurring in the process of solving. You may jot your thoughts down individually or discuss with your groups if viewing this session with others. You may pause the video now and come on back when you are finished. Welcome back. I bet many of you probably said that understanding the problem is where some of your students get hung up in the process. Maybe they can read the words, but they don't seem to understand what the problem is asking. Or they get overwhelmed where there's a lot of text. Do they have trouble explaining in their own words what is happening in the story? Or is it possibly that they are having trouble identifying those relationships where they're just immediately asking if they should add or subtract before they really get any sense making done? Maybe they're looking for those keywords still instead of thinking about the situations. Or are they unable to identify that relevant versus irrelevant information? Or perhaps it's that they struggle to determine how the quantities are connected. For some of our students, it could be the organizing of that information. Maybe they lose track of important information. They don't know how to either even gather all the information and what numbers even matter in this problem, especially as they get into multi-step, multi-schema word problems. Or do they have difficulty representing the problem with a drawing or model as they don't really conceptually understand what the problem is? Perhaps it's selecting a strategy. They know what the problem may be asking, but they don't even know how to get started to solve. Maybe it's an operation without knowing why, or again, those key words that they are choosing. Or it could be that they simply are just guessing and trying different operation until hopefully one works, or they just get frustrated and stop. That's a problem that many of us see as we are working through these word problems, and that's why schemas are so valuable. Because if it's explaining their thinking is where they're getting hung up in the process, that's something that we really want to dive deeper into. Because maybe they can get an answer, but they really can't explain how they got it. That, again, conceptual understanding may be weak. Maybe they struggle with the math language, or they just have difficulty justifying whether their answer even makes sense. So, before we go any further, let's get back to our roots. Let's remind ourselves what schemas are. Schemas are those problem structures that help our students understand what is happening in a mathematical situation and how those quantities in a problem are related. They help us to recognize patterns, organize information, understand relationships, determine relevant versus irrelevant information, as well as selecting the appropriate strategies and operations needed to solve the problem more accurately and efficiently. Let's recall that that most of our elementary word problems fall into two broad categories, all being under the umbrella of routine word problems. And those are additive schemas and our multiplicative. There are three under additive, if you recall. They are the total, the difference, and change. And three under the multiplicative, which are those equal groups, comparisons, and then ratios and proportions. Students need to understand how quantities are related before they decide whether they're going to add or subtract, multiply, or divide. So let's keep in mind that our goal is not can our students name the schema, but rather can the students describe what is happening mathematically. When students can explain what is happening, the schemas often emerge naturally. Here are some guiding questions you can use to support your students' thinking as you model these questions through a think aloud. That is a metacognitive strategy that helps our students to start to internalize and process and use them themselves as they become more independent problem solvers. So as we think about that additive thinking, some of the questions you might be able to use for prompts are what quantities are involved? Are amounts being combined? Is something changing or are two amounts being compared? Whereas for our multiplicative thinking, we might be thinking about are there equal groups? Is one amount a multiple of another? Or are we dealing with repeated quantities? So let's think through this as three levels. The first level is really determining what is happening in the story. So before we discuss operations or schemas, we want our students just to be able to understand the situation. So you might be prompting them by asking them, can you tell me what's happening in the story in your own words? Or who or what are we talking about? Or what information do you know? To help our students produce thinking like two people have different amounts. Someone started with something and then got more. There are several groups with the same amount. At the level two, this is really where we want those relationships to start to develop that they can see and connect with the quantities. This is where schema identification really begins. And that is where you as the support can be asking guiding questions such as, how are these quantities connected? Are we comparing? Did an amount change? Are there any equal groups? To help our students' thinking shift to, we're looking at two amounts and seeing how they're different. The amount changed because some were taken away. There are four groups with three in each group. That brings us to level three. This is really which schema does this problem resemble? This is the time that students are connecting those relationships to that underlying conceptual known structure. So you might be asking them things like, does this sound like a compare situation? Are we putting parts together to make a whole? Is a change happening? Do we have equal groups? So that our students can then be able to think through problems in a way that they are going to be able to compare because we're looking at the difference between the two amounts, or this is equal groups because there are several groups with the same amount. So again, when we think about this say this, not that kind of thought process, we're thinking about what does this sound like? So let's take a look at what's on the screen right now as an ineffective or less effective way. So let's say that our students um, are saying, I just don't know what to do. And you might come in and say, well, do you see the word more? Does the word more mean to subtract or add? That might be ineffective because students are then following a rule and may not understand why. So a more effective might be something that looks like this, where your students might say, I don't know what to do. And you come in with, tell me a little bit about what's happening in the story. They may say something like, Maria has 12 stickers, Jamal has 5. And then you can come in and support with, are we putting them together or looking at how they are compared? And students can reply with, we're comparing them. And then we are again prompting with, what are we trying to find? How many more Maria has? It could be their response. So, what type of situation does this seem like? We ask. And they say a compare problem. So, just looking at the less effective to the more effective, what are you noticing that you all as paras are not doing in this situation? Did you say that we never gave them the schema? We guided them, we supported their thinking and their reasoning, and that's really what our role as a para is, as a support. We want the students to be doing the thinking. We're just that guide on the side, coaching and supporting and giving them those prompts and questioning strategies that can lead them to a more robust understanding. So, in a nutshell, here is a little bit of a schema identification routine that you can use to help support and guide the sense making and reasoning with your problem solvers. So, it's really about retelling, identifying quantities, determining those relationships, identifying the structure, and then knowing what that represents. So to do that, using schema maps and bar models are really good metacognitive prompts that you can use and encourage your students to use as you support them to organize information, see relationships, and reduce that cognitive load, allowing our students then to be able to explain their reasoning. These resources that we are seeing once again, remember, they come from mathspiral.com. The URL is located on this slide and on some future slides that are coming up. I encourage you all to check those out. And I just want to note that they are constantly adding and updating to that site all the time with the most up-to-date and effective strategies and resources, all which are free and downloadable for you to use. Got to love that. So here are some metacognitive prompts. Again, we have one at an additive schema base and one at a multiplicative. These are those metacognitive strategies that you can use as you are guiding, but then we also want them to become intuitive into our problem solving brains of our students as they can use them independently. As they start to ask those questions, am I putting things together for a total? Do I have two amounts compared for a difference? Do I have a starting amount that is increasing or decreasing? Right? So we can see how these can be prompts for us as guiding questions, but they can also start to become metacognitive strategies that our students are asking themselves. At this time, I'm going to invite you to pause the video and practice with your schema gestures from session 1. That video can be found in that session or at mathspiral.com. In addition to the gestures, you may want to look over the schema maps, prompts, and models in preparation for the next part of our session where we will be identifying the schema structures throughout different word problems using these strategies. And once you have had some time to practice your gestures and you become a little bit more familiar with the schema maps and models, I would encourage you to grab something to write with and write on, and then resume the video to practice using all of the strategies. You will see that there will be some slides that follow as I walk you through the try nows. You may pause and play them as you need, giving yourself enough time to record your responses. Please keep in mind that as we are doing this, the object is not to solve the problem, it's to identify the schema. Once you feel you have all your responses ready, you can push play again and see how you did. Time to think. See you soon. All right, are you ready to try this now? Let's take a look at the word problem schema sheet that we have on the screen to your right. These represent all of our schemas that we are going to be needing to use throughout our time as we apply them to word problems. You notice that I have taken off the ratio and proportions. Those are more in our upper level, fifth and sixth into seventh. Not to say that we don't use some of them, but the general additive and multiplicative ones are total difference, change, equal groups, and set and comparison. But once again, if you are needing those resources and to watch a video about the proportion and ratios, they are on that Math Spiral site. So let's take a look at this first one. The store has 112 fireman hats and 83 police hats. How many hats does the store have? So again, walk yourself through using your prompts and looking at your schema map to the right. Once you feel like you have an answer, go ahead and record it. Do the same for this one. Letter B. The store had 112 hats. Then they sold 83 hats. How many hats do they have left? Go ahead and pause the video to solve and come on back when you're ready. We are now ready for problem C. The store has 112 fireman hats and 83 police hats. How many more fireman hats does the store have? And look that they give us a little bit more information in this one in parentheses. We want to bring our attention to that with our students as well. How many fewer police hats? Go ahead and record your response. When you're ready, come on back. We are now ready for problem D. The store had 195 hats. 5 customers bought all of the hats. If each customer bought the same number of hats, how many hats did each customer buy? Go ahead and apply your schema attack strategies here and come on back when you're ready. Problem E. The store has 83 police hats. There are 5 times as many fireman hats. How many fireman hats are there? Go ahead and solve. Come on back when you're ready. All right, welcome back. How did you do? As we go through these, if you have made any errors, ask yourself, can I find my mistake? And as you do, I want you to really be reflective of how this learning experience felt and how it can help you, one, relate to your students' perspective, but also, two, help you in your thought process to better support the students that you serve, right? So let's see how we did. Let's take a look at A. Were you able to identify that A was a total problem with a total unknown? B was a change problem with an end unknown. And C was a difference problem with a difference unknown. Moving on to D. D was in equal groups with the number unknown. And E was the set comparison with the product unknown. We are now ready to move into the last effective problem-solving practice, and that is a cognitive attack strategy. As we discussed earlier in the session, students who struggle with word problems often don't know where to start. These attack strategies provide a roadmap for our students' thinking through a problem step by step. Rather than guessing, students learn to approach every problem with a consistent process. Attack strategies could also be referred to as solution plans or problem-solving frameworks. The name is less important than the purpose, and that is providing our students with a consistent way to make sense and solve mathematical problems. For our training, we're going to focus on the UPS check strategy as our attack strategy. This is once again from Spiral at Math Spiral. You can find those videos and other resources and watch all of them to get a better understanding of the other different attack strategies that could be used. We are going to now take a look at what each step of this attack strategy looks like. Okay, so the U, understand. That is really where we're wanting our students to be able to read the problem and explain the problem. What students might be thinking is, what is happening? What do I know? What am I trying to find? Those are all those framing words that we want to put into that metacognitive thought process as we do some think alouds with them. And where you can prompt might be, can you tell me the story in your own words? What information do we know? Or what is the question asking? Because here the common struggle for our students is reading the words but not understanding the situation. For the P in our UPS check is to plan. And this is really where we determine how we're going to solve that problem and where the schemas, schema maps, and bar models come into play. Our students might be thinking here as, what relationships do I notice? Or what schemas fit this situation? Or how can I represent it? And we can guide that thought process through our prompts as paras by saying, what is happening between the quantities? Does this look like a compare, change, total, equal group situation? Or how could we show it in a bar model? Because here, a common struggle that we see students having is jumping straight to an operation without really identifying that relationship. The next one that we're looking at is the S for solve, and that's really setting up and doing the math. Here, our students want to be thinking what strategy makes sense and what equation matches my model. We're guiding them with what does your model show and how could the model help you solve? Or can you explain why you chose that strategy? Because here, a common struggle might be that our students are performing computations without really connecting them to the situation and therefore really not having that conceptual understanding. The check. This is very, very important. So many times we just see, our students go in, they do something, and they get out, right? We really want to encourage this process of checking. Does my answer make sense? Is it reasonable? Is it accurate? And that allows our students to start to think about, does my answer fit the story? Does it answer the question that the story was asking? Did I include my units and my labels so that I truly understand what those values are representing? Your prompting could be, how does your answer, or excuse me, what does your answer mean? Or does that answer make sense in this situation? How do you know? Because they're here, the struggle that we may be facing is that our students stop once they get a number or don't complete all the tasks, especially when we get into those multi-step, multi-schema problems. So, a UPS check is not a worksheet strategy, it's a thinking strategy. And when you, as paraeducators, are consistently using this language in the UPS check cognitive attack strategy, students begin to internalize the process. So, we want to understand the situation, identify that schema, represent the relationships, and solve. But don't forget, we then also want to go back and check and be able to explain how we know that this answer is reasonable. This process is helping our students to develop stronger mathematical reasoning and become better and more effective problem solvers. So, during our time together today, we recognize those schema structures. We used our schema maps and bar models to represent the situations. We applied attack strategies to learn how to better support our students through that problem-solving process. And we continue to learn more about how we can support our student thinking through the questioning, modeling, and supports that we use to strengthen the mathematical reasoning and problem-solving skills with our students. Here are those URLs for some wonderful resources that were referenced. And so as we conclude today's session, I just want to encourage you to look at these reflective questions and ponder them as you consider what your next actionable step may be in the work that you do with your students. So as we conclude today, let's just reflect on the things that we explored throughout our time together. And as we do that, reflect on how that's going to impact you and the students that you support. Because remember, the questions you ask, the language you model, and the encouragement you provide can have a lasting impact on how students approach mathematical problem solving. Thank you again so much for joining me, and I wish you and your students a wonderful school year. Take care.